Good afternoon, ladies and gentlemen. Welcome to our Techgig webinar series. Our topic for today's session is Big Data Analytics, Enterprise Use Cases. And we have with us today Mr. Puneet Agarwal. He is a Senior Scientist of TCS Innovation Labs, Delhi at Tata Consultancy Services. Puneet is a Senior Scientist at TCS, as I already mentioned. He heads Data Analytics and Information Fusion Research Group at TCS Innovation Labs. Puneet's research interests include applied research in data mining on time series and graph data with a focus on distributed parallel processing. He has been working in TCS for about 15 years now. He joined TCS Innovation Labs in 2004, before which he worked as a technical architect and in other roles in various mission-critical projects in logistics and shipping domain. He has published many research papers and various international conferences on big data, information fusion, software agility, collaboration, and model-driven interpretation. So without any further delay, I will quickly hand over the session now to Puneet. Puneet, I now make you the presenter.
Okay, thank you.
Puneet, I must say that your voice is absolutely not audible right now.
Okay, can you hear me better now?
Yeah, maybe if you continue speaking for the next 1 or 2 minutes, I can tell you.
Okay, good afternoon, everyone. And first of all, I'd like to thank Techgig.com for giving me an opportunity to connect with you all. And I'm very excited to talk about big data analytics, enterprise use cases today in this webinar. So if you think the voice is okay, Sri Lagna, can I continue now?
Yeah, it is better. Just make sure that you're keeping your handpiece very close to your mouth while talking.
Okay, thank you. So let's get started. As we all know, a lot has been talked about what is big data. And many versions of this definition of big data is available on the web. And I don't plan to spend any more time describing it all over again. But still, just to set the context, here are what we're talking is we are talking about how to do analytics in the era of data deluge that we witness today. And the sources of this data deluge are some of what has been depicted on this chart. For further details about footprint of big data in the enterprise world, I encourage you to visit our website at www.tcs.com, where we have published a big data survey of how people feel about it. Going further, let me give you the outline of this talk. I first plan to give you a quick 10-minute tutorial of what is machine learning and what is data mining, with some example of sentiment analysis on unstructured text. And then I will get into 2-3 use cases, followed by which I try and generalize these 3 use cases into something called enterprise information fusion. And finally, at the end, I give miscellaneous use cases of enterprise information fusion. So, getting started, statistical machine learning, which is a branch of artificial intelligence, has one of the most popularly used method called classification. Here, typically we are given with some training data like shown on this screen, using which the computer learns a pattern. Then on a new data, we can predict the same aspect. For example, in this case, we are given some dresses that have a label marked already. And these classification algorithms automatically learn the patterns between the data and the labels. And after that, given a new data or test data as shown on the right hand side, the red shirt and the yellow shirt dress we can predict the label as to who would wear them, a male or a female. That's just an example. But let's just take a quick look of how does it work. So the often asked question is, why can't we do this using rules? Why do we need machine learning or artificial intelligence for it? Well, there are many reasons for it. Some of them are that there are too many rules required, and secondly, that it will suffer from low accuracy rates. But then how does machine learning solve this problem? In machine learning, we first extract some features, like in this example that we just saw in the previous chart. We would extract some features with respect to size, color, and shape of our dresses that we talked about, and then build a probabilistic statistical model. There is something which holds it in the memory, which sometimes creates a decision boundary, as shown in this example with some red line, which is finding a decision boundary that left-hand side samples are different from right-hand side. And then given a new data, we are able to identify what is the new label in this particular case of binary classification. There are some examples that were shown on many techniques of classification on the right-hand side. Let's now look at yet another technique or method which is frequently used in machine learning, and that is called clustering. Here, we group the data based on similarity of features. For example, here we have grouped some dresses based on the similarity of features between them. Moving forward, let's take a look at yet another example, and this is the last in my list, which is we call as anomaly detection. And here the objective is to find outliers. These methods learn a pattern of normal behavior first, and then we are able to identify the odd one out. Like in this case, we can find out that the fourth shirt from the right is anomalous, or is not as what the others are. So to summarize, there are many techniques which are listed on the left-hand side, and just to claim that they are not exhaustive, there are many more techniques. Some of them we have learned just now. So there is something called binary classification that we saw. Then there is multi-class classification, where the classes are not just two, like in our example we had just two, male and female. Clustering, where we want to group items or data sets based on similarity between them. We'll see a detailed example of these in my use cases further. Anomaly detection, and many others like regression, ranking, frequent pattern mining, and many others. Similarly, on the right-hand side, we've got some tools, which are things like Apache Hadoop, Giraffe, Mahout, Weka, POS-Tagger, which is part of Speech-Tagger, Porter-Stammer, and many such things. So let's look at an example. We've seen some techniques, what enables big data analytics. Let us now look at some examples of how this gets realized. So let us say we have got a lot of tweets. I assume that all the audiences are already familiar with what is called Twitter, and where a lot of tweets happen short text messages. And the objective is that we want to categorize them, that they are either giving a positive opinion about the object being discussed, or a negative opinion, which could be a political party, or it could be a new mobile phone being launched in the market. But the challenge is the rate at which these tweets arrive is really very high. So how do we do? What do we do in this case? So we often model this problem, for example, using classification. We do the feature extraction, like we talked about earlier, the color, shape, etc. What kind of features would work in this case? Let's take a quick look, and then we delve into what is called the use cases for something. So here are some features that we can extract. And those can be as simple as words. Those can be n-gram or unigram. There can be some words which indicate time. There can be some words which indicate URL. You can use number buckets because people often tend to use numbers, 1 million, 10,000, and things like that. And we can have numbers and discretize these features based on these buckets. People use emotions, smileys, etc. We can use those. We can extract them and then build some kind of probabilistic model which says that what is the probability of this tweet being positive if such a feature is used or such a feature is not used, using something called classification, which we learned in some of previous starters. And then there are some more features which are listed here. There are some mathematical terms we can just ignore. And believe me, this is just the last chart of my tutorial. And we can then quickly go into use cases. But then this helps us classify these tweets that we get. For example, either in the positive category or in negative category. So now we've seen a quick tutorial. I think I was very quick in giving this tutorial because I wanted to spend more time on the use cases. And here is my first use case. But before I proceed further with my use cases, let me draw your attention towards the bottom of this screen where I have listed some text, which is actually a pointer to some of my publications or our publications from our group at TCS. And these publications will point you to the exact documentation on the web as to how exactly these use cases can be realized in terms of core algorithmic details of which I cannot talk about in such details in this session today. Okay, so coming back to our first use case, imagine a situation that we witness some natural calamity. For example, earthquake or tsunami. Events of this nature attract global attention. They appear almost in every newspaper in every country. And but however, there are some small events, small-time events, such as fire in a factory, which don't sometimes even make it to the national news, forget about international news. And it is observed that the cumulative losses because of these small-time events is also significantly high because they silently disrupt the supply chains. Today, we have globally distributed manufacturing process or supply chain process. How does it affect? According to a survey which was conducted back there in 2011, it was observed that 85% of 550 companies observed that they witnessed at least one supply chain disruption in the last 12 months. So that's the extent by which today's supply chains are getting suffered because of such accidental events, such as fire in a factory or labor strike. So how do we solve this problem? We can detect these events from medium like Twitter. We all know that Twitter is being used in almost 200 countries or more. So there is enough data available on social media where people report about such events. Can we glean such information and use it for enterprises? That's the challenge. So obviously, there are four components. Let me talk now about how do we realize this? How does it work? What happens? How do we sort of make this happen? So there are four components in a solution like this. The first one is detection of events or tweets. The second is correlation of textually similar tweets. And then we extract some information out of these tweets in terms of what is the factory name, what is the city name, etc. And then we correlate these tweets to say that all of these tweets belong to the same event, and then raise an alert or something like that. Let's see the details. What are the challenges involved in this, and how do we solve that using the tutorial that we've just gone through? So the first challenge would be that let us say we are looking for all the tweets which have the word fire and the word factory. And here on my screen, I show some of those tweets. Those marked in red color, as you can see, they do not indicate occurrence of an event, whereas those in black do indicate about occurrence of an event. So what do we do about such spam tweets which do not? Well, now we know what to do. Having learned the tutorial, we can do the classification, the binary classification. We can say that a tweet is a ham or a spam using something called machine learning classification, which is available in tools like Weka, Mahout, etc. And then every tweet can be examined. We can use linguistic features. I don't get into gory details of what features are to be extracted. As I said, you can look up in the research publications around these to see the exact details. Now, having done this, the next challenge for us would be that how do we group these tweets which are similar, textually similar? For example, I have marked them with blue, green, and yellow color on my chart. Well, the challenge here is that we need to do, if we have about, let us say, all the tweets of last 3 days in memory or in some data structure or some place, we need to compare every incoming tweet with all the tweets of last 3 days, just to ensure that this tweet is not similar with any of those. If it is, we need to group it with that. And we need to finish all this processing before the next tweet arrives. And in my experience, just to share it with you, I have observed on regular days, at least regular days when there is not much happening, at least about 1 tweet per second is the rate of arrival of such tweets of fire in a factory. So you can imagine every second or one, or in case there is an event or there is an event of larger magnitude, there are even 10 tweets per second about such topics. Well, there are techniques like hashing used. Details again can be seen in the publications. So that's yet another challenge that's usually solved. The third challenge that is witnessed in doing the analytics here is of information extraction. The information extraction challenge is we want to find out which of the word indicates a location, which of the word indicates a factory name, as highlighted with blue and red color in some of these sample tweets. And we all know there is something called Stanford Natural Language Processing Technique, which is available as an open source, which can identify these things. Given the text, it will tell you which one is a proper noun, which is what, and then you can actually find out whether it is a location or not, or a factory name or not. There are some tools already available, open source, out of the box. But do they work? Not really. The reason is that the text used in Twitter is informal language. It doesn't follow rules of English grammar, and that happens a challenge. But in this particular case, we in our lab created something called some purpose-specific information extractor, which can work with informal language as well. Moving forward, that's not the end of the challenge. Here appears yet another challenge. That having got these tweets and having identified these words exactly, that which of the word indicates a location and which of the word indicates a factory name, and likewise, we're not sure whether two words, like in this case, are referred to the same location. Greenwich is a location in London, and can we say that Greenwich and London are about the same thing? Are these tweets are talking about the same event? Textually, there is no similarity, but still, we want to be able to say that they both belong to the same event. How do we do this? Well, there was a simple technique that we used where we would lay down a circle on the map of some radius, and we'll find out the highest degree of overlap, and that will indicate the place of occurrence. And believe me, the challenge is not simple, because if you talk about London itself, there are about 17 Londons or more, if I recall. Forget about the United Kingdom in United States itself. Okay, so there lies the challenge, and that requires some such sophisticated technique to be able to disambiguate that when you say East London, which London is being discussed here. Moving further, after this information extraction, we are able to correlate all the tweets together, and we've got a structured object out of unstructured text, which tells us when the event has happened, what is the event, wherein exactly, and is it major, minor, etc., based on various things. Having detected these events, we can use them. But let's just take an example. Here is some example that got captured some time back. And as you can see, this event occurred at around 6 a.m. And before that, there was a warning tweet that was tapped by such systems, which is about an hour before or more, which says there is a smoke coming out of this. That's an early indicator. So for such events, even early indicators are possible from Twitter. So having got these tweets, I take an example here. What can we do with these events, which are structured objects? We can take these events, fuse it with our enterprise data, check whether this company is a supplier of my supplier, and be alert and be careful and plan accordingly ahead of time that I'm going to witness a shortage of supply of such and such raw material. That, ladies and gentlemen, is the power of big data analytics. Okay, so I assume that you find this use case to be interesting. With that, let me move on to something more. Let me try and generalize this further. So what are we trying to say? What we're trying to say is that there is a lot of information out there on the web. If we listen, parse, do hashing, classification, extraction of information, do clustering, boosting, a lot of things we do learn, and we can detect events such as those listed on the right-hand side, which is fire in a factory, or strike, labor strike, or flood, or even promotions of a product, or discounts being offered on some certain products. Then what are people requesting? What are the challenges they are facing in the services sector? What can we do with these events if we can get? That's what is shown on this chart. Like in this case, we've seen the first one, but let's take the middle one, where we got some promotion on discounts being offered by some competitors. How can it impact my sales? Can I look at sales history and make some prediction about it? And that's really the objective here. So let's take a look at the middle one here, the middle example. That looks interesting, I assume. Because I've chosen specifically this example because before I saw there were some people who were writing onto the Techgig forum that they are from database world, and this particular use case, the second use case, is about related to something which is about data. So here is a traditional extract, transformation, and load kind of picture that is often used in the world of business intelligence projects in the IT sector. Here we extract information from multiple source systems, put it in a staging area, apply some transformations on it, and then load it into what is called as enterprise data warehouse. And this process is called type 1 ETL, and then from this enterprise data warehouse, we further extract some more information and publish into data marts which work in departmental silos. For example, for one data mart for sales department, another one for marketing, another one for managing procurement division and things like that. And they extract various reports from those data marts, which help them take their business decisions. Here I take a specific example and I show a sample schema of the data that we get here. So there are 4 input tables shown here, a point of sale data, and there are 3 more tables. So let me describe these 3 more tables briefly here. That they are about some surveys or some point of sale data is about what is being sold in a retail store, multi-brand retail store. And these 3, MISC, SOS, and OOS would refer to something like, is my product out of stock? Is it there on the shelf? If yes, what is the share of the shelf that my product gets? And miscellaneous such questions. But the challenge is that these data are collected by different agencies, different departments, in some situations, different companies altogether. And these databases are sitting separately in different platforms, different systems. it is hard to integrate. Not only because of technological challenges of diversity of platform, but also because of format. And let's look at that challenge. But before I look into that challenge, let me try and tell you that for those who love Hadoop, Pig, and Hive, here is a very good example of how to use those such tools in this particular example. So you got transaction system on one side, and you got ETL, which can help us achieve what I talk about in the next chart. So here is what we're talking. Let us say we've got point of sale data, we've got out of stock data, share of shelf data, and social media as data and the top as shown. The social media data is something very similar to how we detected events, which we talked about in our previous use case. So we've got some dimensions here, as you can see. There is something called temporal dimension. All of these dimensions are stored in a different format, as you can see. One of them would store it as week number, another one as exact date. Well, that's solvable. Yeah, people deal with such things. What is the further challenge? Let's see. Well, many of them will use store number, but social media, people use city names. Product names. Well, formal systems also use different names, as you can see here in this example. But social media, you can never say what name will they use. Just imagine yourself sending a tweet, something like, I could not find 56510 primer surface in store number 322, Chicago downtown. Well, we don't write such tweets. We use informal language, and even if you're able to extract events using something, using an engine like what we talked about in previous use case, it is hard to integrate such a data, harmonize such a data in a flat table like what is shown at the bottom. Well, that's the challenge. How do we solve this? So we solve this using what is called as data harmonization, which is what I talk about in this chart here. How exactly do we achieve? Well, it's simple. It is not hard. And in the sense that we first formulate pair records, pair of labels. We have some training data. We have some test data. Test data actually keeps coming in production, but training is built in the beginning. And we extract features like those explained in the top right corner, Jaccard similarity, cosine similarity, etc. Having extracted these features, we do feature selection that are more effective, and finally use something called support vector machine, which is nothing but binary classification, which simply says, does it match or not? Straightforward. Details of this again are available in the publication mentioned at the bottom of this page. And then what is essentially happening here is, so we've got multiple sources of information on the left-hand side. We get this mapping done automatically by this machine learning related, data mining related technique. And then on the fly, we are able to join the data coming from multitude of sources, which is often voluminous. So we use techniques such as MapReduce on Hadoop and things like that. What can we use it for? Well, we can fuse this data with the history data now and generate some alerts which were not possible earlier. Not at all, because we were earlier looking at these reports in their silos, and we were trying to do human correlation, which is hard to do, as we know. Let's look at the example of what kind of benefit do we draw out of such a data harmonization. Like shown in this particular example on the top, there are sales volume shown for 2 years for various weeks, W10 to W17. And as you can see, the sales has gone down in 2011. We don't really know why it's going down. Well, now it is possible to associate a reason exactly as to why does this happen. Because we often struggle with finding out whether this is the reason, or is it some other reason? For example, the competitor has launched something or something like that. So there is no the concrete reason known for dip in sales, often by these sales executives or area sales executives or things like that, or people like of that profile. Let us look into another benefit of such an example. Another benefit is, let us say in some geography, the competitor launched a promotion. And in that geography, in that year, like shown here in the example, in week 6, the sales were dipped because of the competitor launched a promotion. Later on, in week 22, the same competitor or similar competitor announced a similar promotion from the web. And then we are able to detect that from social media. Can we correlate? Can we raise an alert that sales executives better be careful, your sales are going to get hit in the next time to come, or weeks or so? Well, that could be yet another benefit. The third example, I'll quickly talk about this. This is the self-understanding type, that if there is a drop in share of shelf of certain product for some reason, on an average, obviously the sales will go down. But can we detect things? That's yet another example shown at the bottom here. Let me now quickly take you through an iPad app which can enable all such kind of an engine and be shown to a sales executive that this is what they should look at when they're getting things like that. Let me now talk about the third use case briefly, which is about entity resolution problem. So here the problem is that we have multiple documents about entities. For example, people. You have Twitter ID, Facebook ID, LinkedIn ID, Techgig ID, and things like that. You have to correlate the people that all these IDs belong to such a person. Similarly, in enterprise case, you can have CRM system, partners database, supplier database. Can we say that this company has all this footprint in these databases? Well, that's a challenge. That's a big challenge because of textual similarity problems. How do we solve such a challenge? Here is a quick picture. In the interest of time, I will quickly pass through this. Basically, what happens is, again, a set of techniques such as clustering, such as classification, are applied in this case, and they are grouped, resolved, matched, and finally you arrive at a final entity about across multiple databases or sources of information. Okay, so we've seen 3 use cases briefly. Let me try and generalize now, because I plan to sort of bring an end to this conversation. I'll talk from my side and start attending to some questions in another 5-10 minutes now, so I should try to generalize this. Here is what we are generally talking across all these 3 use cases. What we are saying is, let us start from the look, what you see on the left-hand side, which says, search, summarize, and explore. So that's something you look out from the web, like in the first case. The second is listen, which means listen to this social media, or it is a structured text, or it is unstructured text, or things like that. Then learn from these, which again involves techniques such as clustering, rules, subgroup discovery, and other such techniques. Finally, connect, which is similar to fusion, like in this case of our data harmonization example, how we fuse the structured data with unstructured data from social media. And then we predict as to what's going to go wrong or what's going to happen. Can we make corrective actions? That's really the task of correct, which I have not discussed in this forum given the time constraint. But details are available in the respective publication, as I already said. Let us now move on to a list of public use cases, which I'm sure you will find interesting. So we talked about some of these already. In Enterprise BI, we've got various use cases: Enterprise Data Warehouse, real-time data harmonization, multi-structured information fusion, and discovering insights beyond dashboards from an iPad app or things like that. Relational data analytics, we discussed something called entity resolution. There are other things like relationship discovery between people, between companies. What are the relationships? Can we do enterprise search on the data? Those are other big data analytics use cases. Then on temporal data, from sensors, time series data, detecting frequently occurring patterns, detecting events such as anomalous events or accidental events or any surge event or anything like that. From time series data. Time series data can happen in electrical systems, in electromechanical systems, in stock exchange. Everywhere we see time series data today. And Internet of Things is being talked about like anything in the industry today, and temporal data is all omnipresent in all those fields of interest. And finally, behavioral pattern analytics, which is where we can detect some kind of indication of demand of products based on interest of people on various products and services on the web. They tweet about, they write about in the public forum. Okay, with that, I think I have just ended about a few minutes before because I was seeing a lot of questions already. I would love to attend to some of those questions. And allow me a little time to read that.
Yes, thank you so much, Puneet, for the presentation.
Okay, so the first question comes from Ranjan. And the question is it only because petabytes and zettabytes of data is getting created? Or how do you differentiate between data analytics and big data analytics? Very good question. Very good question. I think as far as the enterprise data is concerned, within enterprise, they don't usually come across zettabytes of data, even the large enterprises. So I don't think we always talk about such a large volume of data. It's the combinatorics that makes it challenging. Let us say the example that I was taking of, suppose you've got millions of tweets or trillions or billions of tweets, if not trillions. Comparing them, resolving them, sorting them will require zeta or time operations or 10 power 12 time operations unless you come up with some really smart computer science based algorithms. So it's not about volume of data. It's about when you perform these algorithms, this combinatorics makes it hard. That really is, in my opinion, the challenge of big data analytics. All right, the next question is it a big data scientist really need to be a statistician? Okay, very interesting question, though I think I'll try and answer that from my experience. I think it is definitely better if they have a knowledge of statistics, but I don't think it is mandatory because there are many tools available on the web, such as Veka, Apache Mahout, and many others, which wrap all the mathematics underneath and give you the out-of-the-box functionality. But yes, if you want to use deep analytics, definitely deeper knowledge is required. Okay, next question is from Anurag, and he's asking, in your experience, tweet arising from out of India, adequate in terms of number of predicting the types of use cases you have mentioned? Oh yes, very much. witness tweets from all across the world, and especially in these types of situations, these solutions, some of these solutions that I've talked about today to you, they have been deployed in our customer locations, and there is ample amount of data for coming out from Twitter these days. Okay, the next question is from Vikram Mirani, and the question is, do we need an enterprise data warehouse for doing big data analytics? Okay, a very interesting question. Depends. It's a architecture question. It depends on your big data analytics problem. Every problem is different. In some situations, you need, and some other situations you may not need. Depends on what is the objective that you're trying to address, or what is your final objective towards your. So I think it's a very hard question for me to be able to answer with clarity as to do we need it or not. In some situations, yes, and in some other situations, not. Okay, the next question is, what is the role of Hadoop in this? Excellent. The Hadoop role I talked about in the data harmonization situation. So once you are able to extract these events from Twitter, these events lie in a database, and the volumes of data from these multiple systems, like the example that I took, point of sale data. Imagine how large the point of sale data would be for a large multi-brand retailer like Walmart or Walgreens or for that matter, Big Bazaar in India and things like that. Imagine the point of sale data volume. So yes, it is hard to do without Hadoop. Hadoop is very important, and how exactly Hadoop is used has been mentioned in the publications that I've annotated on bottom of my charts in every discussion that I have had. The next question is again from Sushil, and from ETL and Hadoop, which one is useful for big data analytics? Well, both. Hadoop is used for ETL, many places, many situations, so that's the answer. Next question is from Balaji, and he's asking how machine learning data is getting processed. Please let me know any specific use cases. Well, I think I did talk about machine learning use cases in this talk today, and if you can, I think these things are being recorded, so you can go back and see. And machine learning is used in almost every use case that I talked about, whether it was classification of tweets to say that whether the tweet is actually informing you about occurrence of an event, or is it just a spam, just by chance the two words fire and factory occur in this case, or whether it is another problem of clustering where you want to group the tweets which are textually similar together with respect to textually non-similar tweets or things like that. So there are many use cases of machine learning. Machine learning is almost, I think, widespread in big data analytics today. Very good question there. Can you clearly differentiate between business intelligence and business analytics? Also, please differentiate prediction and forecasting. Excellent question from Vijaya Sarthi Krishnan. Very interesting question. I'll take a little time in answering this, and I'll try to be clear. So, business intelligence is about generating reports, being able to do OLAP reports, online analytical processing reports, which have multi-dimensional data, which are shown to the users, which are like MIS reports. That's primarily where business intelligence happens. Analytics is about using this information and taking a step further and doing, because number of reports that get generated in every department in an enterprise are becoming larger and larger, and they become difficult for people to be able to browse. Can there be an automated system that can draw our attention that this part of the report is what you should look at? Some kind of an analytics, like the use cases that I talked about earlier. Okay, so that would be an example of business analytics. Prediction. Prediction is something where I can say that this is about to happen based on history pattern. For example, in the use case that I talked about, there was a competitor who launched a promotion in another geography in earlier part of this year, and later in the year, same competitor launches promotion in yet another geography. Can we predict that the sales are going to go down because of that again in another geography? That's a small example of history pattern based prediction. Another example of prediction can we predict part failure of my car for a car manufacturer. They do various types of mathematical analysis that how many parts of my total number of cars sold in the market are going to fail in next 6 months, so that I can accordingly budget my warranty cost. That's prediction. Forecasting. Well, sales forecasting. Can you forecast the sale? So that's based on techniques of regression or things like that. So I don't know if I've been clear enough, but I made my attempt. So those are the differences between these things. The next question I should move on to now, Abhijit Das is asking, how do we overcome the challenge of understanding a tweet which has been written using poor language skills, which ordinarily may have been understood by human mind? Excellent question. You can see the details in my publication that I have listed there on that page, on that chart, how it is achieved. You basically have to build, in a sense, the NLP engine all over again for that kind of language. So it's very hard to build a general purpose, informal language, natural language parser. But for specific purpose, such as detection of a location or detection of a factory name, it is possible to build purpose-specific natural language processors, and those are listed, the details are listed in our publication. You can learn from this and build on some smarter things further. Okay, that's a very nice question. Then I move to the next question. So 3 people are asking, Arihant, Alek, and they're saying, when stepping into domain of big data analytics, would you recommend going with either machine learning or data mining for focused approach, or would you recommend the fusion? If fusion, please provide some pointers. Okay, the pointers I have already given. If you look at the recording, there is a paper we talked about. It was published in Fusion Conference, which is listed in Chicago, I think about a year back or 2. Sometime back, I don't exactly remember, and that gives you the information about fusion. As far as the pointer is concerned, about recommendation, either machine learning or data mining, well, it's a hard question. I think both of them are, they're so interspersed that it is hard to say that which one applies where. I think most of them apply in almost all situations. Okay, the next question is coming from Pankaj Pandey. And he's saying that to get into big data, do I need to be IT savvy, with BI and data warehouse knowledge? Well, it depends on the role that you want to play. If you do have to learn something, if you want to do. So if you want to get into big data, means what? In what role? If you want to be a data scientist, yes, you do need a lot more knowledge. If you want to be thinking of newer use cases, newer applicability of big data techniques, well then your whatever education you have is sufficient. You just need to be a voracious reader of the web and blogs and other forums. And as far as you can read things on your own, thinking of such use cases shouldn't come hard, and depends on creativity of your mind also. Okay, the next question is, can you emphasize on QA role in big data? Excellent question from Tejasvi SN. Well, QA is really hard. Imagine a situation that I'm not an expert in QA on big data, but yes, it's a hard problem, and there are some techniques available that you can check the output at a final aggregate level, but the verification on sample basis is done. That's typically what we have seen. For example, just to substantiate this, what we do is, in the case of Twitter example that I took, let's say I've got 10,000 tweets which I have manually annotated with respect to whether they indicate occurrence of an event or not, like fire and factory. And all those tweets have lots of words fire and factory. Now I want to, I've done the classification, but I want to test how good is my classifier. Typically what is done is you push in another set of, let us say 1,000 tweets, which you manually set and tag. It is hard to do to sit and read 1,000 tweets, but it's worth it for testing purpose. And then can you calculate the rate of accuracy, precision, recall, things like true negative rate, false positives, false negatives, and then report the accuracy. So those are the types of things how testing is done for machine learning related algorithms. And that's how the validation is done. The next question is from Deepak Karmakar, and he is saying that, does MapReduce programming model provide a way for reducers to communicate with each other? In a MapReduce job, can a reducer communicate with another reducer? Excellent question. All right, programming question there. Okay, so two reducers need to talk to each other. Well, that's very hard unless you have a third job. That's one option. The better option is depends on your use case. If you're using your data, underlying data is graph for that matter, and you're doing iterative processing, then you need to then there is a way. There is something called Apache Giraffe, where it is feasible. There is something called aggregator in Giraffe, which can be used that multiple workers can talk to the central unit. Otherwise, the other options people have used is they can read information. It is possible to read information from other reducers. Something like I think global cache people have used, but that's really hard, frankly speaking. That I don't know if that can scale to large volumes. On small clusters, it works. Some kind of cache, but essentially, in simple words, it's really hard, and I really have to see how exactly can you do this. But otherwise, generally, I would say getting two reducers to talk to each other is really hard. The best method would be then let all the reducers write to the hard disk and finish their job, and they could write to different folders, different information. Then yet another MapReduce job can look at specific folders and then reunite the information or things like that. Some such stopgap arrangement needs to be made like that. Okay, I think so far the last question in this list. Do we need to use any external tool for performance analysis and tuning, or it comes with integrated platform with big data tools? Oh, there are more questions coming. So do we need to use any external tool for performance analysis and tuning, or it comes with integrated platform with big data tools? Kiran Kumar. Well, yeah, that's again a very hard question. You guys are asking really tough one. I don't see, frankly, I have not seen any performance tuning tools like in case of Java. There are many tools available, but on Hadoop and such platforms, performance tuning is really hard because that involves mathematics. So far, all the efforts that I've seen, they are there in the research community, research world. There are research publications about optimization of MapReduce jobs by various methods of hashing and data distribution. But I have not seen a tool in my experience so far. I don't mean that there is none, but at least I have not seen. Okay, the next question is from Raj Kashyap. Can you provide domain-wise use cases where sentiment analysis can be applied like retail or telecom? Okay, sentiment analysis. I've had a mixed feedback, observation on this. I don't know. I'm not a data. I'm not a business analyst. I'm more of a data analyst. And what I've seen mixed opinions from people because it's fairly obvious that, telecom service providers can continue to check their sentiment about their products, offerings, promotions, because often it's hard to measure the return on investment on new promotions or marketing efforts that you make. This, just thinking aloud, it can be a means to measure the return on investment for, let us say, a marketing exercise. If the sentiment about that product, which is being marketed heavily in that period, improves, or something like that. Okay, moving further. Oh, so I think it's called scroll down. Okay, my question is, I'm pursuing data scientist program conducted by TCS for BPO associates. Excellent. Being with BPO for 3 years, when I suddenly started pursuing a course in big data, it is really hard to learn in a short span of time. What quality makes me an successful data scientist, and what kind of effort do I need to put to become a successful data scientist? Well, that's more of a career guidance question than a technical question. And I think, yes, you need to learn. If you want to be a data scientist, you need to be a good programmer. You need to have a good hold on mathematics, basic statistics, probability theory, data mining, and things like that. But it more comes with the usage. I think it is, if you're going through a suitable training, and TCS has a very elaborate and nice training program, as I'm aware of, and I think they should be able to do justice. But yes, the learning curve is hard. But telling you one thing, it's very interesting. It's so powerful. You feel after learning these things that you can see that there are so many nice things that you can do, and it's very encouraging. Yes, I agree with you that you have to put in a lot of effort to learn various topics. And in fact, just to tell you, there are many courses available on things like places such as Coursera, NPTEL, or many such open source open universities on the web, where they give you a full-fledged course on big data and related technologies. Okay, what security-related precautions one should take in big data analytics? Dhrumil Shah. Well, one of the most frequently asked questions is this. Okay, and I think this is beyond the purview of big data analytics. I think this question is, so far, in my opinion, has to be dealt with by technical architects, not by data scientists. Because analytics would generate the analytics output. Whether this output, this alert, this business intelligence queue should be shared with the person or not, or whom all should it be shared with, that depends on the architecture. Regarding intrusive security measures into big data, there is a lot being talked about, but again, it's a very hard question, and frankly, I have not done much of a work in this area, and therefore I'm not the right person to be able to sort of answer this kind of question. Okay, the next question is, we generally process the existing data using big data tools? Is there a way to process the real-time data and get real-time results? Very good question. Jatinder Arora. Oh, he has left, by the way, but still, for the benefit of others, remarkable question. See, online, you don't do analytics. When you want to do pattern mining, when you want to do detection, you do it in offline analytics using Hadoop or such techniques. Online, you use tools such as complex event processing engines to see them on the line, online. But having said that, in case of Twitter example that I gave you earlier, you do require online analytics, and that takes a complex algorithm, which is what I described already about. So in some such special cases, specific example, architecture and technology is required. Does cluster reducer work in isolation or in clusters? It works in clusters, in every cluster, and it is isolated from all the other reducers. I think there you need a basic Hadoop knowledge. And if you read about any MapReduce architecture or a tutorial on the web, they should be able to easily tell you that how this thing works. So there's a very clear answer that all reducers are independent of each other and they work in the clusters. So both points are yes. Is cloud computing related to big data, or cloud computing is part of big data? Excellent question there. Yes, cloud computing is very much related to big data, because in many examples, many enterprise use cases I've seen, cloud is coming in a big way to channelize this data. That's where part of the processing or the whole processing may happen. That may push some of the data to the enterprise, not all. And then some further processing may happen within the enterprise data center, and likewise. So it's a complex architecture that I've seen obviously many times. People have used cloud for downloading these tweets directly, because cloud, the infrastructure is better. The availability from the software engineering perspective is better. So you gather such data quite a lot from on cloud, do some basic analysis of these tweets or social media data, and only selectively chosen data is pushed into the enterprise data center from various places as is deemed necessary. So yes, big data is definitely related to cloud computing. Whether cloud is part of big data or big data is part of cloud, well, I'm too small of a person to be able to say make such a statement. But I think they're all technologies which work, which have their own identity. And I think that's it. Is that right, Sri Lagna?
Yes, Puneet. We do have around 5-7 questions left, but I think we are running out of time. So I'm going to request the attendees to take up the questions with you offline by coming on techgig.com and putting their queries on our discussion forum.
Surely. I'll have I'll enjoy talking to people and interacting.
Yeah, and I think it's a great platform where you can also come in, post your replies to all the queries that you get, and also for the attendees, I think it's a great place to come and interact with the other fellow professionals.
Okay.
All right. Thank you so much, Puneet, for taking time out today and doing this great presentation with us. And I hope to have you again for one of our future webinars. For all the attendees. Yeah. Go ahead. Sorry.
Yeah. Go ahead. Sorry. I was just saying thanks for all the nice words. I don't know if people find my talk informative, and
no. They definitely did, because the kind of questions that poured in today, they definitely were engaged throughout the session, and I expect that they are going to turn back and send us more such relevant questions after the webinar gets over today. So thank you so much. And the attendees can come on techgig.com on Monday afternoon to see the recording of today's session. In case of any feedback for the session, any suggestion, Any further query, please feel free to write to us. And as I said earlier, please feel free to come on techgig.com to post your queries for Puneet to take them up offline with you. Thank you so much for your fair participation and making this webinar a great success. Thanks and have a great weekend, you guys.
All right. Thank you. Can we hang up?
Sure.
Linda?
I am going to end the webinar,
Okay.
so need not worry about it. Thank you, Puneet.
Okay. Thank you. Thanks everyone. Bye.